morning, everyone. It's time for us to get started. I'm going to do a fair amount of notes today. And I'm actually going to be using you lot as a guinea pig as well, but we'll talk about that later. I want to focus on this section, numerical summaries of quantitative data. And this is actually going to help you with the last two questions from the previous homework to this one. So what do we mean by numerical summaries of quantitative data? You collect a whole load of numbers, that's quantitative data, and you want to summarize it. And the kinds of things that we're going to summarize it with would be the mean. Right, you would probably call that the average, but statistics call that the mean. You know, you add up all the numbers and divide by how many. So if your data was the 10 quizzes I got in a quarter, wouldn't the mean be what you got if you added them all up and divided by 10? Wouldn't that number kind of give you a general idea of how good or bad you did in tests? Right. We're going to do another guy called the median, which does a similar job to the mean. It kind of tells you what the typical score is. We're going to do a thing which is called a 5-figure summary, which is 5 numbers that kind of tell you a lot about not just where the typical number in the middle is, but the extremes and, you know, various other places. I'm going to look at a particular diagram that we use very often to visualize a 5-figure summary. So these two belong together. And the diagram that uses a 5-figure summary is called a box plot. You might even have heard of it. You know, a box plot is one of those things that look like that. Yeah, you might have seen them somewhere, right? That's a box plot. We're also going to look at numerical summaries, numbers that tell you something. One's called the range. The range is like the difference between the biggest and the smallest number. So I might say I have a whole load of data and the range is 20. That means from the smallest to the biggest, you know, there's a difference of 20. And then we do this weird guy with a weird name. It's called the interquartile range, IQR for short. And this is a number that gives you an idea of how spread out the data is. So that's the kind of the list of the summaries, and in one case, a diagram that we're going to use. So I am going to use you lot as a guinea pig. So I'm going to collect some data right now. And once we've collected that data, we're going to use it to calculate these things, just to show you how you would do it by hand. And then I'm going to show you that you can collect the same data using your TI-84, which kind of makes your life a lot easier, trust me. Although it's a bit messy at the beginning, it's really helpful towards the end. And we'll see how that one goes. Okay, so the question I am going to ask you is how many siblings have you got, including you? So it's your brothers and your sisters plus you. So if Ashton, if you're the only one in your family, which I know you're not, the answer would be 1. But if there's you, your brother, and your 2 sisters, that would be 4. Right? Now, just so we are being consistent, there's no judgment value on this. Can we just make it full brothers and full sisters? Because sometimes we have blended families and you might have stepsister or a half brother, whatever you call them in America, right? And so on. So just, you know, full brothers and sisters. I can't think of another name, just to keep the data consistent, because some of you might be using 1 and others might be using a different way of measuring it. Okay, and it's all to do with volunteers. So I'm going to start, and I, including myself, there were 10 in my family. So you just basically shout it out and I'll try and write them down if I can hear them. Go for it.
1.
1.
3.
1.
4.
3.
1, I heard the 4. I think I heard the 3.
2.
2. A couple more and we'll call it good.
10.
Oh,
Oh, were you already measuring mine?
no, that's mine. Your 10 is your own. And one more?
6.
6. Okay. Now, what we've done here is essentially the beginning of statistics. Haven't I collected some information, right? I've collected some data. Now, if I just left it in that list, well, it tells you something, but would you agree you can't really tell a lot? You're like, what's the typical size of family for people who take statistics in Olympic College. That's probably the best label I could give this, because you're not a typical American, because no group really is. The first thing you would do in a situation like this, before I would even think about this, any of these, is it's very often useful to put the data in order, right? Probably smallest to biggest is what most human beings do. So that one goes first, that one goes second, that one goes third, check, no more ones, okay. That 2 goes next, no more 2s. That 3 goes next, that other 3 goes after that. That's the 3's done. That 4 goes next, that 6 goes next, and 2 10s. Now, it's not much of an improvement, but would you agree that when you put them in order, it's a little bit easier to tell what kind of numbers are in people's families? Can you see there's quite a lot of ones now? Is that a little bit clearer? And there's 10 is the biggest, 1 is the smallest. Do you get a better feel? Not a lot, but it's better. So putting data in order is a very useful thing to do. So let's look at how to calculate some of these summaries, and we're going to do them by hand. And then I'm going to show you how to do it on a calculator. Right, now if you want to get the mean, don't you just add them all up and divide by how many there are, right? You would probably say the average, but mathematics and statistics would call it the mean. So let's check how many there is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By sheer coincidence, I didn't know I was going to be that good. There are 10 numbers. The usual convention in statistics is n represents how many data points you've got. So in this case, n equals 10 would tell me that. So I know that I'm going to divide by 10. And here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 21, 31, 41. And the answer I got is 4.1. Essentially what that's telling me is that a typical group of students, and I'm not talking about this 10, but imagine we went and looked at everybody in Olympic College and asked the same question, right? It's round about 4, right? 4 siblings, you and 3 others. Right, 4.1 just means it's a little bit bigger than 4, but typically about 4. Can you see how that would work? If the number was 4.5, wouldn't that mean somewhere between maybe 4 or 5 would be the kind of average number? If it was 3.1, wouldn't it be more likely there's about 3 people in a family? If it was 3.5, it's somewhere between 3 and 4. And so doesn't that kind of give you an idea of the typical family size in the middle? It's about 4. I believe in America, the typical family size, oh God, don't quote me on this, but you can look it up to check it yourself. I think it's 2.8. So it's about 3 children roughly. Right? So some families have 10, right? Mine is, but some have 2, right? And the average is out about 3. Now, why is that helpful? Well, do you know if you did the same thing to different places in the world, that number would change? For instance, if you did that same question and you asked people in France, do you know the answer would be a lot lower? The typical family size in France and Germany and most of Western Europe is about 1.8. It's not even 2 children. It's almost not replacing the population, which is why a lot of Western European countries are very slow growth. Most of their growth is immigration. America's got quite a healthy internal growth rate, right? Family size growth rate. And we have a very healthy immigration rate as well, which is why America grows quite quickly. Scotland, for instance, where I come from, has had a population of about 5 million for the last 100 years. It's been 5 million 100 years ago. It's about 5 million right now. You know, give or take 100,000. And the reason for that is partly to do with family size. Family size in Scotland's about 2.1, I think. Not as big as America. And secondly, it's to do with, and I'm an example of it. Do you know most people emigrate from Scotland, not emigrate to Scotland? So we lose whatever it is, 50,000, 100,000 a year to people going to other places in the world.
Pickles are driving them away.
Oh God, no, the pickles aren't. The pickles are the reason the harder ones stay. So are we comfortable about how to get the mean, right? And you can use that to compare different countries. Can you also use the mean? It doesn't matter how big the size is. Suppose I went to Kentucky and I asked 200 students their answer. Wouldn't I still come back with a single number? Now, it might not be the same, probably won't be, but at least it would be, oh, Washington tends to have a bigger family size than Kentucky, or whatever the conclusion might be. Now, the next one is called the median. I don't know your experience of statistics, because some of you might have heard all of these terms, and some of you might only have heard one or two of them. The median, if you put in English, it's the middle number when the data is in order. Okay, so I know I don't need to write these down because they're there, but I want to because I'm going to write on top of it, and I don't want to waste this data set after spending all my time putting it in order. In this case, there are 10 numbers. So wouldn't the middle number be position number 5, right? Guy number 5. Well, let's show you what that looks like. 1, 2, 3, 4, 5. It's this number here. But wait a minute, if I count from this side, isn't 1, 2, 3, 4, 5 this number here? Now, by sheer bad luck or coincidence, aren't both those numbers the same number? So in that situation, the median is 3. Now, what that's telling me is that the typical family size in the middle of the data, right? It's not the small families, it's not the huge families, it's kind of the one in the middle. It's about 3. Now, can I show you, because I don't know what our data was going to be like until I collect it. Can I show you a different data set to show you what you might have to do to calculate the median, right? So let me show you some other situations. Let's suppose we did, who knows what this is? 1, 2, 3, 4, 5, 6, 7. Right, let's suppose I have 7 numbers, right? 7 data points. Which guy is in the middle? What position? 1, 2, 3, 4, 5, 6, 7. What guy do you pick in the middle when it's an odd number like 7, 9, 11? Because you can't pick 3.5, right? That doesn't exist. You pick guy number 4. And let's see why that works. 1, 2, 3, 4. 1, 2, 3, 4. Would you agree that that guy is in the middle? So in a funny sort of a way, when the data is odd, isn't it dead easy to find the median because there's only one guy in the middle? And if you're wondering where the 4 came from, just add 1 to that and half it and look for guy number 4. Right, so that's position 4 I'm talking about, right? The 4th one along. And that's our median. And the other situation will look something like this. And it kind of happened here. So how do you get the median when there's an even amount of data, right? There's 6 numbers or 22 numbers or 100 numbers. Well, the median is in position 3, which is kind of what you'd think. But look what happens. 1, 2, 3, 1, 2, 3. Isn't it more likely than not that the two guys in the middle will be different numbers. I mean, in this case, we got lucky, right? But in general, isn't it more likely that they're not going to be the same number? So how do we figure out the median? What do you think you do when you have two numbers to pick and you want one number as your answer?
Could you add them together and find the average?
You do. That's exactly what you do. So what's that? 8.5. And yeah, I know you don't get 8.5 people in a family, but you don't get 4.1 people in a family either, right? Isn't this just a number that's in this data set? It's, well, I wouldn't like to guess where that country is, but in this data set, the typical family size is somewhere between 8 and 9, right? The one in the middle. So that would be a weird country, but whatever it is, that would be the answer. Do we feel comfortable now about how to calculate the mean and the median of a data by hand? As long as the data is in order, add them all up and divide by 10, or find the middle guy, depending on which of these two circumstances are. Okay, let's move back over. And let's now calculate what's called the 5-figure summary. If you take a set of data, like this set of data here, the 5-figure summary is made up of, not surprisingly, 5 numbers, 5 figures. There's a guy called the minimum. There's a guy called Q1. There's a guy called the median. There's a guy called Q3. And there's a guy called the maximum. The guy that's called the median is sometimes, but not very often, called Q2. And it kind of makes sense. If that's called Q1, this should be 2 and this should be 3. Right. So we're trying to figure out how to calculate each one of these guys. Well, 3 of them are dead easy. So let's get them out of the way. Would it make sense that the minimum is the smallest number and that the maximum is the biggest number? And the median is the median. So there are only 2 numbers missing, isn't there now? This funny guy called Q1 and this other funny guy called Q3. And these, by the way, are called the quartiles. That's the name you give to both of these. This one and this one are called quartiles. And if you want to be really precise, this is called the first quartile and this is called the third quartile. And the median is sometimes called the second quartile. The word quarter and quartile is not a coincidence, because Q1 and Q3 basically tell me where in this data line you should go so that you've got 1/4 of your data, then 2/4, that's half your data, then Q3 is 3/4. So that's what these guys do. So I'm going to show you how to find Q1 and Q3. I have to start with my data set again, so I'm writing a nice clean version because there's too much going on in the other ones. And we already found the median. Remember, the median was between these 2 3s. So I'm going to go here and I'm going to draw a little invisible line and I'm putting in the median. And that's 3. That's also called Q2. Now, that little dotted line, I want you to think of that dotted line as being an invisible wall. And what it has done is it separated my data into 2 halves. I haven't separated it into the 5 small numbers and the 5 bigger numbers. So far, so good. Now, forget about that side. These numbers here, you find the median of them. You find the middle of them, and that's Q1. Now, in this case here, are we comfortable with these 5 numbers, that one there is Q1. Are you happy that the middle of those 5 numbers is that one there? That, not this one or that 2, but this number 1 right in the middle, right? Position 3. Okay, look at this set of data. Which one of those is the middle one? The one that's going to be called Q3?
Is it 6?
It is.
6.
Agreed. 6. Does that make sense? How I calculated Q1 and Q3. So Q1 happens to be 1 and Q3 happens to be 6. And we have now found the 5-figure summary. Our data started at 1 and it finished at 10. The typical one in the middle was 3. 1/4 way along was still 1, so that means there was a lot of 1s. And 3/4 of the way along, it was a 6. And that is called a 5-figure summary. Now let's do a range and an interquartile range. Let's get these guys done with, and that's us basically done the numerical summaries. The range is the difference between the biggest number and the smallest. So you get the range from here. The biggest we had was 10, the smallest we had was 1. So the range is 9. Now, the range gives you an idea of how spread out the data is. And can you imagine I said to you, oh, I did this same thing with one of my calc classes, and the range was 4. Now, I didn't tell you any of the numbers, but the fact I told you the range is 4, doesn't that probably mean that everybody had, give or take a little, isn't everybody quite close to each other, right? All the numbers were, well, from the biggest to the smallest, there was only a difference of 4, right? Suppose I said the range was 20. God, you wouldn't get that in real life. But suppose I said the range is 20. Wouldn't that mean that the data was really massively spread out all over the place? If I said the range was 1, wouldn't that be basically almost everybody was 1 or 2 numbers, right? Right next to each other. So range is very often used as a measurement of how spread out it is. Okay. Analogy. Imagine you were a golfer. I'm not, but imagine you were a golfer and you recorded how many shots it took you to do an 18-hole course, right? And you did it lots and lots of times. And you have a twin brother who does the same. And your range is 4, right? 4 shots, right? So for the most you took to the least you took, it was 4. And your brother was 14. Wouldn't you be a pretty consistent player if your range is 4? Not saying you're a good player, you could be consistently bad, but at least you're consistent, right? You tend to do it, give or take a little, but 4's not a lot. Now, your brother was 14. Doesn't that mean he's all over the place? I mean, sometimes he might have a great game and sometimes he spends 2 days finishing the course. So that's what the range does. So does the interquartile range. It's another way of measuring how spread out the data is. And it has a formula. You subtract the value of Q3 from the value of Q1. And the value for the range and the value for the interquartile range, there's no reason in the world why they should be the same, and they typically aren't. They're measuring the same kind of thing, but they're doing it differently. The interquartile range is basically measuring how far apart the middle 50% of the data is. And that's normally considered a better measurement, because don't you just need to have one extremely big number or extremely small number for the range to be large? Whereas if these numbers are extremely different, these numbers here won't matter. They don't care because these all stays the same. Any questions so far? Are we cool about mean, median, 5-figure summary, range, and interquartile range? We feel good about those guys. Okay. Last fella I'm going to do is a box plot. So let me just make a new data set. Let's suppose I gave an exam and this 20%, 20 is what the worst score was, and then it went 40, 60, 80, and somebody got full marks, 100. There's the 5-figure summary. So I collected all the data and I got the 5-figure summary. I would like to use this to visualize it, to make a picture. And the picture that we're going to use is called a box plot. It's also called, at least back home it's called, a box and whiskers diagram. I like that name better than a box plot, but box plot is what we're going to call it. And how do you represent this visually? Well, to create a box plot by hand, you use a ruler, not the way I did it. And since I know the numbers go from 20 to 100, I'd start at 0 and I'd go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. I draw a scale, and you know, there's nothing wrong in starting with a number that's not 20. You don't need to start at the smallest. And sometimes it's a good idea actually to start at a nice number. So see if the smallest number was 52. Do you know, I might start my table at 50, right? And then go 60, 70, 80, and so on. Then what you do is you take the minimum, which is 20, and you make a little mark. And I tend to then do the maximum at 100, and I do a little mark. And then Q1 is 40, so at 40 I draw a longer line. Q2, which by the way is the median, right? I draw, it's at 60, so I'll draw a line there. And Q3 is 80, and so I draw another one there. And then the long lines get joined like this, and the short lines get joined like that. There's a box plot, not too hard. Are you comfortable about how a 5-figure summary can generate a picture? Any questions so far, or are we still good? I'm looking at faces. I'm not really seeing happy faces. I might be seeing tired faces, but I don't think I'm seeing any faces that look like it's weird. I'll assume that we're good to go then. So we've looked at how to collect some data and find mean, median, 5-figure summary, range, interquartile range, and how to draw a box plot. Now, you might be wondering why I didn't use this to do one of these. So let me show you why I didn't, but it's possible to do it. My data starts at 1 and finishes at 10. I would still put 0 in, even although that doesn't make sense, because you can't have nobody in the family, because you're in your family. And the reason I avoided it is that these two numbers are the same. And I didn't want to confuse the issue, because hopefully most of the time these numbers are always different, right? And so the picture looks like this. But let's show you how you would do it. The minimum is 1 and the maximum is 10. So that's the same. Q1 is 1. The median is 3 and Q3 is 6. And you join it like this, and you do that. Do you see that this poor little blocks plot has lost its tail? These are called tails or whiskers. Well, the reason why I like the name box and whiskers is, can you see a box and some whiskers? Kind of reminds me of the shape. Now, do you notice that this, because the Q1 and the minimum were both 1, do you see how you lost your tail or your whisker? So that's the only reason I avoided doing that one, just because it would have probably distracted you. This is what most box plots look like. But can you imagine sometimes one or more of these numbers might be the same number, in which case the shape gets a little bit distorted because of that. I'm surprised no one asked me why I didn't do that one. So that was the reason. So I'm now going to show you how to do pretty much every single one of those calculations using the calculator, the TI-84. So we're going to go back in. I'm going to set up the calculator. You should be looking at a TI-84 right now. Are we good?
Yeah, I see it.
You see it. Okay, so if one sees it, I know you all see it. I'm going to take some data, just like we did. So I'm going to use you as guinea pigs, but I'm going to take a new set of data so we can do it differently. And we're going to calculate all the same kind of things: mean, median, range. Well, the range and the interquartile range, we get them because we know what the mean is, and we know what the max and min are and so on. So I'll switch the thing on and I'll hit start. So if you want to do this with me, you can. So I'm hitting start, and right there, do you see it has number 1 edit? If I hit enter, I'm looking at a table that looks like this. So I'm now going to collect some data from you. And this time I'm going to collect volunteers only. So if you don't want to, you say nothing. Your age. We'll see what that looks like. I'm going to join in. So there I go, 65. Just shout it out and I'll stop when I feel like it or when data runs out.
21.
18.
Oops.
37.
20.
32.
I heard the 20 and I think the other one was 22.
32.
Oh, it was 32. Okay, just scroll back up and overwrite it. Dead easy to fix a mistake, right? Notice how I did that? Let's pretend you were typing in some data and you said, oh, flipping heck, it's 32, not 22. Does that mean I have to start again? Nope. Move the cursor up, change it to whatever it should be, 32, hit enter, and just keep going. Let's say you don't know until too late that 18 should have been 17. Go up to 18, rewrite 17, it's fixed. Oh, wait a minute, I was right the first time. Go to 18, 17, call it 18. So it's pretty easy to fix, right? Okay. Be nice to get a couple more and then we can call it quits. Anybody else want to volunteer their age?
17.
One more for fun and giggles. What we got?
18.
18, right. So what we've done here is put all the data, right? I've collected the data. I've not written it down on paper. It's just in the calculator and it's in a place called, you see in my case, L1. That just tells the calculator in line 1, if you want to call it line 1, all my data is stored. Now what I'm going to do is this button here, it's called stat, statistics for short. I'm going to hit it. Now, I've got an old emulator, that's this guy. Some of you have a slightly better version of a TI-84. So what I'm about to do now might be slightly different for you, but it's essentially the same thing. When I move over to calc, I choose number 1, 1 variable stats. Now, when I do it, I see that. But some of you will see a funny little table where it has L1 and all the stuff done for you. If you've got the new modern version, it'll just say L1. All you do is hit enter, 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 enter until it's finished, right? In my case, I have to tell the calculator where to go looking for the information, the data, and it's in L1. Now, it's hard to see in this, but will you trust me that the number 1 has a blue L1? So I hit the blue button 1, and you see the L1 appears. And now I've got the data in L1. And when I hit enter, we should have all sorts of numbers, most of which you don't want, but they're there anyway. So let's look at what all those numbers are, and I'll kind of write them down as we come across them. It would be nice if they called them what I called them, but you see that funny guy at the top with an X with a line above it? It's called X bar. That is the mean, right? So if you want to know what the mean looks like, it's called X bar. So I'm writing that down. The mean of this class is about 28.5. So the typical age of people was roughly about 28.5. All this stuff here, forget about it right now. Scroll, scroll, scroll. As I keep hitting that, do you see it kind of shifts up? There. Now, do you see this bunch of numbers here? Isn't that essentially the 5-figure summary? So I've got the minimum. In this case, it was 17, and I know that's true. It wasn't 17 the youngest person that we got information from. And then I've got Q1, which is 18. I've got the median, which they call MED, but it is the median. And it's what, 20.5. And then I've got Q3, and that's 34.5. And then lastly, I've got the maximum. And the maximum was 65. Do you feel comfortable that you could probably duplicate that if you needed to yourself with, say, a different data set if you had some questions? So
How did you get to the first part where you put in the information?
Sure. So as if we were starting from beginning, clear this out the way, probably. You hit start. Choice number 1 is edit. You hit it, and then you type your numbers in. Is that what you were asking, Aston?
Yeah.
Yeah. Now, can you imagine that you had a second question to do? But there's numbers from the first question, right? Staring you in the face, like right now. How do you make that work? Well, the slow way of doing it, but probably the safest way to do it is delete, 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 and then start from scratch. There is another way of doing it where you go up here and you hit clear. I don't like telling people that because they go up there and hit delete and they destroy L1 and it's gone, and then they don't know how to make it come back, and it's a pain in the butt to make it come back. So if you want to do it again, it's just easier just to hit delete, delete, delete till all the numbers go. I mean, it only takes, what, 30 seconds? It's not a big deal. Are we comfortable now? Any other questions about that? Remember, this is recorded. So if you forget it or you thought you knew it, but now it's not working, you can always go back. If I had a modern version, I could show you that's, you know, the bit where you hit start and you do one variable, you'll get a little menu that's got L1 in it. So in a way, your life's easy. You just keep hitting enter until it tells you the answers. That's the only difference. Now, let me take all that data. Yes. What you got?
I have a TI-36. I was just gonna YouTube and see if I could figure out how to do it with the data. I don't know if you know ahead of time if it works with.
I have not a clue. I
Okay.
can't help you. If it doesn't work, if it just doesn't have this feature or it isn't really doable, whatever you want to call it, you might want to think about getting a loaner on the TI-84, just because I do a lot of things on the TI-84, not just this, but later on I'll be doing intervals, and trust me, there's tons of stuff that I can do with it on the TI-84. Now, if your calculator can do all those things, okay, you go to Zoo, you go to YouTube and you figure it, and that's great. But unless it's a pretty sophisticated one, it probably won't do some of the later stuff. So it might get by with this, but then you won't be able to do confidence intervals, for instance, right?
Yes.
So,
No.
yeah, I wouldn't want to say go and buy one. They're about $100 odd, which is probably too much money for anybody for 1 quarter. Unless you're lucky enough to have lots of money, in which case can I get someplace? Otherwise, although I've had students have told me they went into thrift stores and got one for $10 because they were just lucky. If you've got a kid at school, a high school kid, they very often use TI-84s. You could steal it for a day, use it. Beat up your little brother. There's another way of getting one, if he's got one. But you kind of do need a TI-84 for quite a few different things. Right, I've ranted on enough about that. Let's get this guy. I need to know the range. The calculator doesn't do that, but I know how to get it. Don't I take the biggest and subtract the smallest? So the range would be 48. And the interquartile range is Q3 subtract Q1. In this case, yikes, that's an awkward number. 34.5, take away 18. That's 16.5, I believe. Do you want me to draw another box plot, or can we pretend that you know how to do that so we can move on? Do you want me to do a box plot with this data? Would you like to see it? I need a yes or a no. I'm just getting some. Megan, do you want to see one? Yeah, we got it. Let's do it. So imagine I've got a ruler. I actually think square paper is very helpful, but it's a pain in my butt for me to do it. All right, I know I'm going to go from 17 to 65, so I'll probably start at 10, right? And I'm going to go 20, 30, 40, 50, 60, 70, right? So it's a bit like a ruler. Now, 17, can we pretend 17's about there? 18, oh, let's do the big guy. 65 is about here. 18 is right next door. 20.5 is pretty close. 34.5 is about kind of sort of there. The Q1, 2, 3 make a big box, and the little guys make some whiskers. Are you happy with that very, very quick version of how to draw a box plot, right? Min, max, Q1, 2, 3. Why would you need that? You know, some of the homework questions says, here are 4 pictures of a box plot. Which one is it? Well, if you draw one of them, can't you just have a quick look and say, yeah, the second one looks like this, and that's how you choose it. So there are questions where you are being asked to do a box plot, and the way they check that is to give you a choice of 4, one of which will be this. Are we good again?